The magnetic field is decreasing. It's growing weaker and less bipolar. So there's a reversal. It's a time in the life of the magnetic field during which the field doesn't have just two poles, one north and one south. It has numerous poles and is not as strong. When people think about the poles reversing, they imagine the magnetic north starting to slide south, while the south magnetic pole slides north. What actually happens is that the magnetic field grows weaker, way down to only around 10% of its current strength, and when that occurs, the field becomes less and less bipolar. So, that means that on the surface of the Earth, numerous magnetic poles pop up. Several magnetic north poles, several magnetic south poles, and all these poles start to move in a complex interweaving dance. The dance only ends when the magnetic field gets stronger again. As it strengthens, the magnetic poles gradually clump together, and we're now back to a bipolar situation with a magnetic north pole and a magnetic south pole.
When the process of magnetic reversal does occur, it may last for thousands of years. During that time, the magnetic shield will be like a sieve for cosmic rays. What will happen to us when we lose half or more of the protection that guards our planet? Will solar and cosmic radiation become a threat to life on Earth? In the last 150 years, the magnetic shield has lost 15% of its power, and it's losing more every year. Is this a sign that the reversal is already starting? Gauthier Hulot is worried about what he sees in the South Atlantic.
There are places on the Earth's surface that we need to keep an eye on, such as the South Atlantic. The so-called South Atlantic anomaly is an area where the magnetic field is much weaker than in other areas at the same latitude. We know that a cascading series of similar phenomena is what leads to a reversal.
Our wandering pole is reducing the power of our magnetic shield, and scientists are monitoring the field on a daily basis. Larry Newitt and fellow scientists around the world are now keeping a close watch on solar activity and any fluctuations in the magnetic field. Their network is called the Intermagnet, which stands for the International Real-Time Magnetic Observatory Network. In Canada, intermagnet data arrive at the Geomagnetic Laboratory, located near Canada's capital, Ottawa. This is where Larry works.
There's extreme activities of over 900 nanotesla, so I don't know.
That's pretty big.
It is.
And what about the solar wind speed?
It is actually very fast, so I don't know how should we react on that.
Yeah, well, this is pretty big. Okay, well, I think we better issue a warning. That's big enough to affect the electrical utilities and everybody else.
With the lowered intensity of the shield, Larry and others have noted that we are more and more vulnerable to radiation from the sun.
The sun is continually shooting charged particles at us, and every once in a while there's an eruption in which we get a very large number of energetic charged particles that hit the Earth's magnetic field and cause it to oscillate or to vibrate or to change very rapidly.
For the moment, it's the northern latitudes, where the shield is far less effective, that have felt the increasing effects of solar storms. 1994, solar activity damages Canadian satellite Anik E2, interrupting communications throughout northern Canada. 1989, a solar storm causes an electrical blackout throughout the province of Quebec. Because of its proximity to the magnetic pole, this system is sensitive to solar storms and variations in the magnetic field. In Western Canada, the vital pipelines of the oil and gas industry are sensitive to the Earth's magnetic field. Without the shield's full protection, there could be electrical overloads, oil spills, fires, and explosions. You might think that in the age of GPS, we don't have to worry about navigating with magnetism. But the GPS system relies on satellites, and they are vulnerable to solar storms. When they happen, calculation errors could go up to 100 meters. Bad news indeed for industries like deep-sea ocean drilling, which count on precise positioning data to keep their platforms in place.